In this video, we're going to talk about isomers. So by now you've looked at alkanes, alkenes, alkynes, cycloalkanes, and cycloalkenes. And this is usually a good time to talk about isomers. Now, isomers are sets of compounds that have the same molecular formula. So that means they have the same number of carbons and hydrogens and whatever else is in there, but they have different structural formulas. And specifically, these are called structural isomers. Now, in the Chemistry 30 diploma, isomer you could also take to mean structural isomer. That's what it's talking about. There are other more specific types of isomers, but we don't really get into that at this level. All right, on the right-hand side, you can see two isomers, and these molecules both have the molecular formula of C4H10. But their structures are different, so that's why we call them isomers of each other. The one on the top is butane, just normal straight chain butane. You'll sometimes see it written as N-butane. It has 4 carbons and 10 hydrogens. The structure on the bottom is known as 2-methyl-propane. It has a 1, 2, 3 carbon chain, so it's a propane parent, and it has a methyl group coming off of carbon 2. So its name is 2-methyl-propane. A more common name for this is isobutane. If you count up all your hydrogens, you'll also get 10. There should be 3 hydrogens on the carbon on the left. The carbon on the top will have 3 hydrogens, and then the carbon on the right will have 3 hydrogens. And then the one in the middle will have room for 1 hydrogen because it has 3 bonds to carbon atoms, so it has 1 bond remaining for a hydrogen. So that gives us 10 hydrogens, 4 carbons. So since they have the same molecular formula but different structures, we call them isomers of each other. One useful tip for determining whether a set of compounds are isomers is by looking at their general formulas. So this can often save you a lot of time. It can save you from having to count up every single individual hydrogen atom. If you are aware of the general formulas, you can just see if the name or the structure itself will fit that particular formula. So for alkanes, the formula is that the number of hydrogens is twice the number of carbons plus another 2. Alkenes and cycloalkanes have the same general formula. The number of hydrogens is always going to be twice the number of carbons. Alkynes and cycloalkenes have the same general formula. The number of hydrogens is always 2 less than double the number of carbons. All right, so and this typically works for alkenes that just have 1 double bond, and then same thing with alkynes, 1 triple bond. As soon as you start adding multiples of those, then you can't necessarily use these formulas. You do have to pay a little bit more attention, but strictly speaking, in this course, this works out pretty well in Chem 30. All right, so here's a bit of a challenge for you. Can you name and draw all the isomers of C5H10? And I'll give you a little hint. C5H10, since the hydrogen count is twice the carbon count, this fits the general formula of alkenes and cycloalkanes. So that's the class of compounds that you can draw from when you start listing the isomers of this particular compound. All right, so I'm gonna just pause the video here, and I've got the answer coming up. All right, so hopefully you had a chance to write down as many of these as possible. Here's, let's see, I drew 9 of them here. I think I got them all, but who knows? I might have made a mistake, who knows? But I think this is all of them. So the first one, Cyclopentane is a cycloalkane. It has 5 carbons in it, and it should have 10 hydrogens. So each carbon will have room for 2 more hydrogens. So cyclopentane works. The other cycloalkanes I drew here were methyl cyclobutane. So instead of a 5-carbon parent, I drew a 4-carbon parent, and then I have a branch coming off of it. So that works also, methyl cyclobutane. And you can even look at the name too. Cyclobutane, so but means there's 4, and then if I have a methyl group, that's 1 more. So there's 5 carbons there. The red lines I drew here were just to show where the hydrogens would be, and there should be 10 red lines there showing the 10 hydrogens. The other cycloalkanes were down here at the bottom. So dimethyl cyclopropane, 3-carbon parent, and then we have 2 methyl groups branching off. If you draw red lines coming off of these guys, you'll notice there should be 10. The other cycloalkane is ethyl cyclopropane, so a 3-carbon parent, and then we have an ethyl group coming off. So 5 carbons in total, and there should be 10 hydrogens. All right, the next class of compound that this molecular formula will fit are the alkenes. So you can start off with a 5-carbon straight chain, so pent, and then we have a double bond between carbon 1 and 2, so this is pent 1-ene. We could move the double bond to occur between carbons 2 and 3 to get pent 2-ene. At this point, if you move the double bond to go between carbon 3 and carbon 4, you get the same thing as pent 2-ene. It's just just been flipped. So that's not a new molecule. It's just the same molecule just turned around. What change we can make now, though, is we could take one of these carbon branches, one of the carbons in the 5-carbon chain, and we could turn it into a branch coming off of the main chain. So we could do that to form 2-methyl but 1-ene. So it's a 4-carbon parent with the double bond between carbon 1 and 2, and then we have a group, the methyl group coming off of carbon 2. So it's just like pent 2-ene, except we take this carbon right on the end and we put it coming off of carbon, what used to be carbon 3 in pent 2-ene. All right, on the right we could make also 2-methyl but 2-ene, so we could take 2-methyl but 1-ene and move the double bond so it occurs between carbons 2 and 3 right in the middle. And the last structure that we could do is we could take the 2-methyl but 1-ene and we could move that methyl group coming off of carbon 2 to carbon 3. So we get 3-methyl but 1-ene. And there we have it. If I'm missing one, let me know, but I think that's how many I could come up with, I guess, in like a few minutes. So yeah, let me know if I'm missing one. All right, here's a sample diploma question with isomers. So this one shows a list of 3 compounds, and the question's asking which of these compounds are isomers of nonane. So C9H20. So nonane has 9 carbons and 20 hydrogens. It's an alkane, just a straight chain alkane. There's no cycle in there. So what we want to do is we want to look through these compounds and see which of them also has 9 carbons and is just a straight alkane with no cycle. Well, if we look at number 1, it says trimethyl cyclohexane. So this is a cycloalkane. So that means it's not going to fit the general formula, the same general formula of CnH2n. Okay, so trimethyl cyclohexane, because it's a cyclohexane, cycloalkane, I should say, its general formula will be CnH2n, which would make it C9H18. So because this is a cycloalkane, it can't be an isomer of an alkane. If we look at compound 2, it's got a pentane, so it's got a 5-carbon chain, parent chain, and then tetramethyl means it's got 4 methyl groups coming off of a 5-carbon chain. 4 plus 5 is 9. and it's a straight alkane, so that means it should fit C9H20. If you look at compound 3, pentanes, we have a 5-carbon parent, and then we have an ethyl group coming off 3 and 2 methyl groups coming off of carbon 2. So 2 carbons from the ethyl, 2 carbons from the dimethyls, and then we have 5 carbons in the parent, so 2 plus 2 plus 5 gives us 9. So 2 and 3 look like they fit, so that means the answer will have to be C. All right, here's a bit of a challenge for you. This is a diploma question that I've kind of just summarized very quickly, but in this question, it's a numeric response question, and they're asking you which of the following, the compounds here numbered below 1 to 7, are isomers of this compound up here in the top right. Okay, so which of the compounds 1 to 7 are isomers of this compound here at the top? And I'll leave that one with you. All right, see you in the next video.